Alright, I'm going to do the first question that you were given on this sheet of paper. This is how I've laid out the chi-squared test since university, so you can follow it if you want. I make sure that it's laid out like this so I don't miss any steps, and to make sure that I get that I'm getting lost in doing the experiment. So, first thing, I'm going to read the question. Character for stem height in pea plants is a dominant allele giving tall stems. So that gives me my first allele. I'll give capital T as tall stems. And a recessive allele for giving short stems. So I'll give a small t as short. In a cross between two heterozygous individuals, 315 tall and 101 short plants were produced. So I'm going to use my data. T tall, I made 315. Little t recessive, short, I had 101. And it's asking me to use the chi-squared test. So for me to do that, first off, I've got to figure out my expected ratio. So I'll look at my alleles for my heterozygous cross, capital T, little t. I've got one dominant, homozygous dominant, I've got one heterozygous, I've got another heterozygous, and I've got one homozygous recessive. So the ratio then I would expect of tall to short would be a 3:1 ratio. Now, if I had the amount of plants that we've got here in total is 416, so I've got to figure out what I would expect my ratio to be for 416 plants. For me to do that, I know there's probably a fancier way of doing this, but 416 divided by 4, I would expect 104. I would expect 312 to 104 plants. That's what I would expect to get by my ratio. I divided this total number by 4 to give me what 1 would be, and then multiplied by 3 to get what 3 would be. So the next step then, I'm going to put my table together. So for my two alleles, the observed amount of tall plants I had was 315. The expected number of tall plants I have was 312. The observed amount of short plants I had was 101. The expected amount was 104. Now I just follow my table. O minus E will give me 3. O minus E will give me minus 3. And then square these values, which will give me 9 on both sides. And then I've got to do my O minus E squared. This section, take away the expected or divide by the expected section here. So I shall do 9 divided by 312. And that will give me, if I don't press delete, 9 divided by 312, 0.0288. And I'll do the same thing here, 9 divided by my expected, 9 divided by 104, 0.0865. The next step then, I've got to sum these two values. So it will be 0.0288 plus 0.0865. Let me just do that. Plus 0.0288. That will give me 0.115. I shall leave it at that. So that's my chi-squared value. Now what I've got to figure out is my degrees of freedom. So degrees of freedom is the number of categories minus 1. I've got 2 categories here, so I'm going to take away 1, giving me a degree of freedom of 1. Now I've got to see where this value lies in my chi-squared table with this amount of degrees of freedom. So for that, I'm going to skip over to the PowerPoint that I sent you, and I'm going to look at the chi-squared table that is there. So first off, I'm going to accidentally open my emails. Now I'm going to look at my chi-squared. Right, so where does my value of 0.115 fall in that first row, the degree of freedom, the first row? That is in between 0.9 and 0.5. So now for me to properly report this, I've got to write down exactly what I found. I found a chi-squared value to be 0.115 with 1 degree of freedom. So that's 1 mark. The next thing then, I'm going to give my p-values. So my p-value for this was smaller than the 0.9, but it was bigger than the 0.5 margin. Which means that because it's not a statistically significant value, because my chi-squared value wasn't smaller than 3.84, bigger than in between 3.84 and 6.63, because it wasn't in between those two values of 0.05 and 0.01, or a larger number than that, I can say that any difference in those numbers that I observed from the expected number was due to chance. That there is nothing statistically significant about the difference that I've seen, and therefore it's good. Now, I realise it's probably a little bit hard to see this, but it is the exact same thing over and over. You find your alleles, you find the data that's been given to you, figure out the total number as well, you draw your Punnett square for the alleles you've been given, and you work out the expected ratio. You can then work out the numbers that you'll be expecting for your table. Fill in your table the observed numbers, the expected numbers, O minus E squared, O minus E squared divided by E, and then do that for the other allele as well. Sum up what we see. Find your degrees of freedom, which is the number of categories, normally the number of rows, take away 1. And then you find your chi-squared value. Your chi-squared value is 0.115 with 1 degree of freedom. The p-value is less than 0.9 and more than 0.5, values that we'd expect, so the difference was due to chance. And that's how you answer your chi-squared questions.